till now in this chapter we have completed 3 theorems. First one was superposition theorem, second one was Thevenin's theorem, and the third one was Norton's theorem. And now we are going to have discussion on our fourth theorem, which is reciprocity theorem. And we will first understand the statement of this theorem, and then we will see the conditions for which this theorem is applicable, and then we will solve one example problem to understand this theorem in a better way. So let us start our discussion with this statement. In a linear bidirectional single source network, the ratio of response to excitation remains the same even when the positions of response and excitation are interchanged. So according to this statement, when we have a linear bidirectional single source network is a very important point, then the ratio of response to excitation remains the same even when we switch the positions of response and excitation. To understand this statement, I have taken one network N. This network is a linear bidirectional network, and in this network we have one independent source, and this is the only source present. So this network is a single source network. Now I will say this branch is branch X, and this particular voltage source is providing the voltage equal to V sub X, and due to this voltage source in this branch, which is, let us say, branch Y, current IY is produced. This means Vx is our excitation and Iy is our response. And the ratio of response to excitation will be Iy over Vx. And this ratio is going to be same if we interchange the position of Vx and Iy. So we have the same network. And this time in branch Y, we are going to have voltage source Vx. And in branch X, we are going to have current Iy. So here we have Vx as the excitation and Iy as the response, and the ratio of response to excitation will be Iy over Vx. So in simple words, we can say that when we have a linear bidirectional network with single source, the ratio of response to the excitation remains the same when we switch the positions of response and excitation. If Vx in branch X is producing current Iy in branch Y, then Vx in branch Y will produce the same current Iy in branch X. So in this way, we are done understanding the statement of reciprocity theorem. And now we will move on to the conditions in which reciprocity theorem is applicable. Reciprocity theorem is applicable when, number 1, the ratio of response to excitation is either ohm or mho. Here in this case, the ratio of response to excitation is Iy over Vx, which is mho. Condition number 2 is only one independent source is present in the circuit. Pretty easy to understand. Condition number 3 is no dependent source should be present in the circuit. So a lot of conditions must be satisfied before we use reciprocity theorem. Now we will move on to our example problem to understand reciprocity theorem in a better way. We are required to find the value of current I when the network satisfies the reciprocity conditions. So we have a network N and it is satisfying all the 3 reciprocity conditions. Plus it is a linear bidirectional single source network, and we need to find current I in this configuration. So let us move on to the solution. We will first focus on case number 1. In case number 1, we will find out the ratio of response to excitation. The response is 2 amperes and the excitation is 10 volts. Let us now find out the ratio of response to excitation in case number 2. The ratio of response to excitation in case number 2 will be I over 30 volts. And according to the reciprocity theorem, the ratio of response to excitation will remain the same, and therefore 2/10, which is 1/5, will be equal to I/30. From here we will have current I. It is equal to 6 amperes. This is our answer. So I hope this example problem was clear to you, and you understand how we have used reciprocity theorem to find out current I. So this is all for this lecture. See you in the next one.